Okay, so let's move on to number 6, and this one you can actually use equations to solve it. Um, so in this problem, this is number 6, it says that you accelerate from a speed of 0 to 25, and this is really meters per second. That's the velocity here. So this is 25 meters per second. That's how fast you're going. That's that 25 there. In 25 meters, and the question is, how long does it take to do that? Now, I'll draw you the picture. The picture looks something like this. So say, here's your car, the worst car ever drawn. This is the starting point, which is 0. And so this is 25 meters away. And so you're accelerating. So you start out at rest. So you're parked, and then you start accelerating. And so by the time you get to 25 meters, now you're going at 25 meters per second. That's the picture. Now you could use equations to solve this. It's actually better to sort of cheat. And so the easy way to solve this is to notice that the average velocity is 12.5 meters per second. Now this is assuming that the acceleration is constant. If you have a constant acceleration starting out at 0 meters per second and accelerating constantly to 25 meters per second, well, your average velocity is going to be 12.5 meters per second. And so you're going, this is over a distance of 25 meters, which is twice, 25 is twice 12.5. And so since that's your average velocity and distance is rate times time, that sort of thing, then you can immediately say that the answer is 2 seconds. This is a useful sort of thing to be able to do because it lets you solve certain problems quickly, and then you can spend most of your time on the other problems that are harder. Maybe this doesn't make sense to you though, or maybe it's not obvious that you would do this. So if you wanted to use equations, you could use equations. It would just take a lot longer. So let me show you what would happen. So the equations I told you before, I told you 3 equations. X minus x0 is v0t plus 1/2 a t squared. And then v minus v0 equals a t. Maybe I wrote the v0 over here last time, I don't remember. And then v squared equals v0 squared plus 2a x minus x0. Well, the how long, so the question is how long does it take? You're wanting to solve for, so this is saying solve for t, right? That's what the how long means. You certainly couldn't solve for t in this third equation because there's no t in it. So if you wanted to solve for t, you'd have to use either this equation or this equation here. Now this equation looks uglier, it's more complicated, right? And it's quadratic in t, it has a t squared, so I'd like to avoid using that one. Could I possibly use this one? Well, if I solve for t in here, what would happen is I just divide both sides by a, and I get v, well, what I get is t equals v minus v0 over a. Now I know what the final velocity is, I'm told that, that's 25 meters per second, and I know what the, initial velocity is at 0, and so this would be 25 over a. Well, what's a? Well, it will turn out to be that a is 2. I mean, a is 12.5 meters per second squared. And but that's not, you're not given that number. You would have to infer that the same way that I sort of inferred that, you could use the average velocity and so on. However, you could solve for that a in this equation here. So the problem you're left with here is, so this is 25 over a. So the problem here then is well, what is a? And of course, the answer will be that it's 12.5 meters per second squared, but how do we know? How do we know? Well, if you wanted to, you could get it from this equation here. And what you could do is you could say, okay, the final velocity is 25. So the final velocity squared is 625. That's, squaring this. The initial velocity is 0, so I'm going to get an equals 0 here. I have a plus 2a. And then here, the x minus x0, well, the x, that's the final position. That's 25. The x0 is 0, so this is 2a times 25. And so this boils down to 625 equals 50a. Or you could say a is 625 over 50, and then that's 12.5. And then in the end, I fudge in the units, meters per second squared, which is what I wanted here. And then that would allow me to conclude from this that t is 25 over 12.5, which is equal to 2. But that's the same answer I got by just using the average, using a trick, saying, well, the velocity changes from 0 to 25. It changes constantly, so the average velocity is 12.5, and it's going 25 meters, so it takes 2 seconds to do that. I don't know, whichever of those ways works for you. You could use your equations. It takes a while, though. Let's move on to number 7. So in number 7, here you're slowing down. So you're going from 50, so once again, I didn't put the units in here just because of space, but you're going from 50 meters per second to 25 meters per second in 2 seconds. What's your acceleration? So you're slowing down, and well, this one, it's actually pretty straightforward to use an equation. And I could tell, well, let's just talk through it again. There's this equation. I'd rather not use that one if I can avoid it. I have to solve for the a. And I'm not told an initial position, I'm just told how fast I'm going. So I look at this and I think, no, probably not. And then there's v minus v0 equals at. What about that one? Well, I'm given a initial velocity, that's 50. I'm given a final velocity, that's 25. I'm given a time. Well, what do you know? It's easily this one. I don't even have to worry about the next one. So don't even bother. With the next equation. I've got a final velocity. I'm sorry, I got that backwards. Well, I can fix that. So that's 25. The initial velocity is 50. And this is equal to a, and then times 2. That's the length number of seconds. So I get a minus 25 equals 2a. So a equals minus 25 over 2 equals minus 12.5 meters per second squared. That's the answer. So that one was pretty straightforward. And then there's one more. number 8. So here, this one is where you're wanting to stop your car. It says you see an accident, so you're trying to slow down. You're able to slow down at -5 meters per second squared. You start out going at 20 meters per second, and the question is, how long does it take you to stop? What's your stopping distance? What's the stopping distance? So you could start writing equations again. So that's the stopping distance. In this case, it's going to turn out to be the first equation that you want to use. Why? Well, you're asked for a distance, and you're given velocities and accelerations. And so you're going to need, I guess you're going to need a time too. So v minus v0 equals at. And you could write down the other equation, which I guess we're not going to need, v0t plus 2ax minus x0. So what am I wanting to solve for here? I'm wanting to solve for distance. So you could say, well, there's only one distance I'm solving for here, right? I want to know a total distance. So, but I have an x and an x0 here. How am I going to put two numbers into there? Well, you can decide to call the point at which you slam on the brakes here. You can decide to call that distance 0. And you can call it whatever you want, but you can say, this is where I'm starting. And then so the distance you end up at, that's going to be the final distance. So I'm going to set the initial distance here equal to 0. And I'm allowed to do that because I can decide to start wherever I want to. But I'm going to need, in order for this to work, I have an acceleration. I'm told what the acceleration is here. But I'm going to need a time. I'm not directly told a time, so I'm going to have to get a time from some other equation. Now, could I could get a time from here. Looking at this, it seems like I might be able to actually use this equation here as well, because I've got, I'm looking for stopping distance. So if I'm solving for distance in here, I have an acceleration, I have an initial velocity and a final velocity. Oh, well, you could use either. So if I use these two here, what would happen is first I'd solve for time. So I take this equation here and I say v, so this is the final velocity, which is 0. That's 0 minus, what was the initial velocity, 20, equals acceleration. And so this is -5 times time. So this is going to be a -20 and -5 over here. The minuses are going to cancel, so I'm going to get 20 equals 5t. And this is going to tell me that t equals 20 divided by 5, so that's 4 seconds. And then I could plug that into here. So the x is what I'm solving for. I'm going to say the x0 is 0, so I'm going to say x minus 0 is the initial velocity, v0 was 20, the time is 4, and then I have plus 1/2, the acceleration was -5, and the t squared was 4 squared. So this is going to tell me that x is 20 times 4 is 80, and then the minus is going to come out, so this is going to be a -1/2 times 5 times 16. 5 times 16 is 80, 1/2 of 80 is 40, there's a minus sign here, so this is 80 minus 40, this is 40 meters, is the stopping distance. Now let's see if we can get that out of the other equation, just to practice using both equations. If we wanted to try to get that out of the other equation, what we'd do is we'd say the v squared, now this is the final velocity, so this is just 0 squared if you like. This is the initial velocity. This was 20. So this is 20 squared plus the acceleration was, so this is 2. The acceleration was minus 5. And then we have the x. This is the final distance, which is what we're solving for. And then the x0 is 0. So we get 0 equals 400 minus, and here we have 10x. We move the 10x over to the other side. 10x equals 400. Divide both sides by 10, x equals 40. That's better. In this case, it was better to use this one. So this was better. So, but either way would get you there. So that does it for this first set of problems.